All right, welcome. So, who here likes beer? All right, you're in the right place. So, what we're talking about today is Eric and Zulk and I'm Peter Beeth. We've built a 2-barrel, 55-gallon nano brewery. So, it's Eric, me, Peter. I build and test. Jeez. There we go. Is it coming up? Yeah, it's a little messed up. All right, now we'll go with it. Yeah, so we actually given this project a name. It's got a website, OpenBrewery.org, which right now just links to my personal website, but we'll fix that. So I actually build and also test hardware and software for companies. So that's what I do for a living. Eric is an electrician, and he's also a certified master brewer. So what we're going to talk about today is basically giving an introduction to our effort to build this brewery, kind of just cover the brewing process itself. And then also the problems and challenges we face and what we did about them. And then we also have some recommendations based on this project for other makers. So, how do you make a good beer? Is it natural spring water or the best hops? I think there was a commercial that said it's Milwaukee. Or is it just blind luck? Well, it can't be blind luck because there's lots of beers that are good out there. And it can't just be one ingredient. It's actually lots of different variables that go into brewing beer. So, like I said, there's a lot of variables that go into the flavor of a beer and the quality, everything. And so what you really need is you need control over your brewing process to have the same beer come out over and over again. Now, we started as homebrewers making 5 and 10 gallon batches on our kitchen stoves. And the problem with that was after a while, it was great. But after a while, like people ask you to make the same beer that you made last summer or something like that, and you can't get it to be the same. There's just too much changes. And there were some beers which they were good, and they could have been great if we could just do them again and tweak them a little bit. So to go to the next level, we really had to get these variables under control. Now, PowerPoint animation. Forget about that. So when we did a survey, basically of what products were out there for us to pull this brewery off, we found out there's actually a lot of products for large scale. Like if you're trying to build something for that fits in a warehouse, if you're like a real brewery, like you got $150,000. There's plenty of products out there for you from established vendors. On the other end, there's a lot of stuff which you can use, like we looked at the Arduino and so on, and all the products around you here at the Maker Faire. And those were more for small scale things. I guess when you look around here at making in general, it's predominantly for small things, the kind of things that you can hold in your hand. I know Burning Man has like art cars and stuff like that, but it's kind of less common. So we're kind of falling in this middle range, which I'm going to call medium scale making. And that's kind of where you start getting the efficiencies of being bigger. And at the same time, you have the benefits of being small. And we found that was totally underserved. And we'd actually like for that to change. So medium scale making, like I said, efficiencies of scale up. Basically, we make, like for example, a lot more beer than 5 gallons. But we still have the benefits of not having to have this big space and not having to spend as much on everything, like on all the ingredients and so on. So, one question is, how do we enable other medium scale making? Well, we're hoping that by actually releasing the source code that we use for all the code in this and also the schematics, we can hopefully encourage other people to engage in projects that are this medium scale. So let's cover the beer brewing process a little bit. If you want to do that, Eric? Let me see if I can carefully get this off my head.
Alright, is that working? Alright, the beer brewing process, pretty basic process. Beer is composed of 4 main ingredients: water, barley, hops, and yeast. Water is 90% of beer, and yeast is what really makes the beer work. It converts the sugar from the barley to ethanol, the alcohol in the beer that we all enjoy so much. The process is pretty straightforward. Basically, we start with the water, we heat it up to a desired temperature. We add the barley to it to create barley tea by steeping it. Then we boil it for about an hour. Add the hops to it, which creates what we call the wort, which is basically young beer. Then we add it to the fermenter, put the yeast in, ferment it, and age it for a few weeks. Carbonate it, it's ready to serve. In our brewery, we accomplished this by using 4 tanks. 3 of them are 55-gallon stainless steel vessels. The one on the left is called the hot liquor tank. Basically, it's just a hot water boiling unit. In this tank, we have 2 heating elements, which have 11,000 watts of power. We have a temperature sensor and an on-off valve, which we use to add water from city water to the hot liquor tank. Once we get the water to our desired temperature, we transfer it to the center vessel on your screen, which is the mash tun. In this, we add the grain, which we steep with the hot water for about an hour. And while we're adding the water, we have a liquid level sensor, which ensures that we don't overfill our tank. Once we are done steeping, we transfer it with a pump to the boil kettle, where we boil the grain tea for about an hour. And then when we add the hops, it becomes what we call the wort, like I said earlier. And then we transfer it to our fermentation vessel, which on the way there we put it through what we call the heat exchanger. It's kind of like a car's radiator. It cools the wort down to a temperature so we can add the yeast. And once the yeast is added, it ferments, and it's going to be ready to drink in a few weeks. And that is pretty much the beer brewing process in our brewery. Let me get this back to Peter.
It's easier the second time. All right, so major components. There's the tanks, there's pumps and valves, there's a temperature sensor, level sensor, the heat exchanger, the heaters. So actually, as it turns out, you only really need about 4 circuits to run the whole thing. Now, where did we get all the parts? Well, actually, you did most of the buying, but a lot of it came from eBay. There's a lot of Home Depot runs. McMaster-Carr can sell a lot of the newer stuff, like the tubing came from there, like the piping. There's also a place called Brewer's Hardware, which had like the temperature sensors and I forget what else. Oh, a little louder. All right. Brewer's Hardware. Yes, that was good. Okay. DigiKey Mauser. That's where some of the electronics came from, and then also SparkFun. So what do we have actually built so far? Well, there's actual brewery itself. You can see a picture of it here. It fits in a garage, which is one of the goals. There's the actual graphical control software. So that was written in processing, and it just uses an Arduino. And I can actually demonstrate that a bit later here. And then we have a collection of reusable circuits. So we've put those all up on the website. You can go and download them. I actually talked to the OpenBrewery people to get some tips because all of the circuits were documented in PowerPoint, which apparently is not a standard way to do it. So anyway, what challenges did we face? Well, there were actually challenges that we did have, and they fell into 3 key areas. So the first one was existing hardware. One of the things we got really excited about, we tried to leverage as much that was already out there as we could. For example, processing. And I heard about Seed Studio last Maker Faire, and they had some cool circuits that you could use, like this relay board that I'm showing here. And that was, I think the website said it was rated for like 240 volts and 10 amps. We're like, great, it's plenty of power for our pumps. And so we ordered it, and we had our pumps, and when we finally hooked it up, we realized, like, I don't know if you can see the little green terminal blocks where you put the wire in. For example, the gauge of wiring you need for those pumps by electrical code, it doesn't fit in this. And in fact, there's no way a 240 volt 10 amp wiring would fit in there. And we ran the pumps a few times, and then our valve controllers blew up. And after a few hours, we figured out that it was because the traces on this board are so small, and the little holes for the screws are so small. When we screwed it all down, it actually shorted these two little teeny traces out and basically sent 120 volts through our logic circuits, which were up to 10 volts. And so that blew away $200 something. And it's like, great. Well, so that was a problem. I think, you know, we basically one by one had to ditch all this off-the-shelf stuff we got and had to roll our own because it just wasn't built for this scale. Next thing is development tools. Processing is great, but when you really get into serious like testing, and you need to do testing when you're doing something big like this because there's more safety concerns, it doesn't really have anything that you can do. And it's great for getting started fast, but I actually switched over to using Eclipse. I'm a Java developer, and you can write like automated test cases where your code gets tested for you, and it just makes it so much easier. Finally, it was just well-tested libraries and source code. You know, what we're doing is pretty basic. We're like pumping water around, we're heating water, cooling water, and then we're adding stuff to our beer. There's only like really 4 things that we do. And there's no need to kind of reinvent the wheel on writing code. So we're hoping that by releasing the code that we're using, like people can take it and just use it again and improve it as well. So we don't all have to start from scratch. Now, I gotta get to one thing which is important. When you're working with larger scale things, these medium scales I'm calling, or large scale, the cost of failure, it's not like blowing up a $2 or $3 part you bought somewhere. This is, you know, at worst, it's a safety concern. And so you've really got to test things out thoroughly. And I think actually the FDA's guidelines for testing of like drug manufacturing are a pretty good place to take some high-level ideas from. And you got to ask yourself 3 questions with everything you build. So 1, does each of the parts of this system work on its own? 2, does the whole system work once you put it together? And 3, does it continue to work? Because you can run it and things rattle, they shake loose, and they might break over time, and you really need to check. I mean, just thinking about it, like, I mean, there's the heaters are something we were really scared of because then they put out a lot of power, and if something goes wrong, I mean, and you're not there, it could burn your house down. It's like, you got to be really careful. So, next steps for the project, build a better website, number 1. Other features we want to add is actually data logging. We don't have that right now. We want to be able to record batch records and also record like temperature, everything during the whole process. We're going to eventually fully automate this. So you put in the ingredients and hit a go button, walk away, come back 8 hours later, and you have 55 gallons of beer. Finally, all of this should go out on the internet so you can actually monitor it from anywhere. So I'm going to conclude this talk with this nice picture I found on Google Image Search, and it carries the spirit well. Beer will change the world. I don't know how, but it will. All right, thank you. If you have any questions, let us know.